Hey, welcome in a new video. Today we will do another video about the Kubernetes cluster installation based on kubeadm, but we will be especially focused on Containerd. So we will do a video in two parts. The first part will be a theoretical part, and the second one will be in the terminal. We will go over some Containerd CLI examples, and we will install some prerequisites about the kubeadm usage. So let's go. Let's dive into it. And don't hesitate to subscribe to the channel to not miss the next video. You can just have a look in the Kubernetes playlist if you want to have more information about the previous videos. Don't hesitate to like and comment this one to support me. It's really important. And go below this video to check out inside the description. You have a GitLab repository with all CLI slides and so on. Let's go. Here we go. We need to start. And the first part, the theoretical part, what we can say about Containerd, it's really important. And you need to keep in mind, it's turned out that at I think it's 1.24 Kubernetes version, there was a switch, in fact, and before inside Kubernetes you could use the Docker, so Docker directly, the Docker engine, and after that Docker was totally removed from the Kubernetes support. And behind that there is a why. Why is that? And in fact it's due to what we have inside the container runtime. When you take Docker, for example, and you run a Docker run for a specific container, you use a high-level container runtime. So it's classical, it's like Containerd. But when you run the Docker engine use behind the hood Containerd, and Containerd is just on the top of runC. So runC is a low-level container runtime. Containerd is a high-level container runtime, and Docker engine is another, and on the top of Containerd, another high-level container runtime. But the goal is the same. In fact, at the end, the goal is to define or set C groups and namespaces. But yes, we already saw that in the first videos about this playlist. runC is a low-level container runtime. That means it's only dedicated to create the core purpose about a container runtime, meaning create or set C groups and namespaces, and that's it. On the top of it, Containerd is here to, and we will see that, to pull images, create a container, and so on, but without some features, like, for example, it's really important in the Kubernetes context, without the network part. And it's a core, or it's one of the main difference between Containerd and Docker on the top of Containerd, because Docker will provide or provides just the network part, volumes, and so on. But in fact, when you use Kubernetes, you don't need to have a specific network management or volume management, because Kubernetes will directly provide you all these features, but through Kubernetes, not through the container runtime. And this is the why, in fact, why Docker is totally useless when you handle a Kubernetes cluster, when you need to set a Kubernetes cluster. And now we can use Containerd or another container runtime, a high-level container runtime like Rio and so on. But yes, the main goal about the containerd switch, in fact, is to avoid to have some overhead like the network provided by Docker on or volume and so on. So some other things that you need to know. Docker, so the Docker company has developed Containerd and gave Containerd to the CNCF, so the Cloud Native Computing Foundation. So it's like the owner about Kubernetes, and yes, it's how it works behind the hood. What we can say that so to manage Containerd, you have a dedicated CLI, and you can use some other CLIs. Like in our case, we will make in this demo, in the second part of this video, we will use and we will go over the CTR command line. So it's easy. It's like or close to be the same thing like the Docker CLI. It's more almost, in fact, but because you will see there is some difference, and but we can say it's like the same or it's the same spirit, in fact, of the CLI. And yes, to be used by Kubernetes, in fact, this container runtime need to provide a socket to interact with it, and this socket is provided into /run/containerd and containerd.sock. Okay, so now what we can say more in the technical part, so after the theoretical part, how to install Containerd, that depends, in fact, about, of course, the distribution, the Linux distribution. In our case, we will use Debian, but it's close to be it's close to Ubuntu. To install it, it's like a built-in package, so you will have it by default. So you can run it. You can run directly sudo apt install Containerd. In the past, to do that, you needed to install the apt Docker repository inside your server, and of course after that make before a sudo apt update and then a sudo apt install. But basically it's the same thing. You can check, of course, if Containerd is up and running with systemctl status, and you can check the data directory. So it's /var lib containerd, and you can check if you have some container into it. But basically, of course, it's easy. You can do it easily with Containerd. So CTR CLI. Yes, and CTR CLI, you can manage what the community named a namespace, but take care, it's not the same thing like the Kubernetes namespace. It's more a box, in fact, and especially for Containerd, and you can list namespaces and create a new namespace, of course, and list which namespace what do you have. Okay, and after that, of course, the goal and the main goal about Containerd is to create some containers, but it's a bit different if you compare it to Docker, because with Docker, for example, if you run like the second line here, a Docker run -d for the detach, and you pass a path for the image and a name of container. If the image is not already present on the server, the image will be automatically downloaded. It's not the case for Containerd, so that means that you need first to pull the image, and just after that you can use it. Okay, and we will see that we have some difference. For example, to stop a container so to do that you need to use the CTR task and with a kill. And yes, it's really important to have it to keep it in mind. The namespace by default, when you will install your container, your cluster, your Kubernetes cluster with kubedm, the namespace will be automatically created. I don't remember exactly the name. It's like kate.io and so on. And we will do that just after, but as a prerequisite to use kubedm and to install Kubernetes, we will need to set or to reconfigure a part of our system. The first thing is to remove the swap. So the swap, basically on Linux, the purpose of the swap is to extend your memory, but not based on real RAM or memory, but more based on the disk. And that means on the most of applications inside the world right now, it's not really great to use a swap because that can provide some unstable behaviors, and you could have sometimes a slow or slower system, and then after that a good system with a faster system based on the real memory, and that can switch a lot. It's not really easy to understand, to deal with that, and this is why it's better to disable the swap. Of course, the installation of Containerd, and then we will just reconfigure Containerd. By default, Containerd can manage directly cgroups because it's a high-level container runtime, and it just uses runc. And by default, we have a parameter systemd cgroup set to false. That means that Containerd can manage directly cgroups, but in our case, and by default, and as a prerequisite of the kubedm usage, we need to say, okay, we prefer that systemd will manage cgroup rather than Containerd. And yes, that's the things about Containerd. Two other things about the prerequisite of the cluster installation. There are two modules inside the Linux kernel that we need to ensure to enable. The first one is overlay for overlay file system. It's usually it's used by a lot of or plenty container runtime, and for Containerd we need to ensure that we can use it. And the second module is the BR netfilter, is to ensure that netfilter, so on the top of IP tables, can handle package managed by bridge. And this is a really important module that we need to ensure to enable. And to persist this parameter, to ensure that if we restart the server, we need to set it inside a specific file inside /etc module -load.d. Okay, so let's go and we can have a look inside the terminal. What we can do, the first thing that we can do, of course, is to use apt install, and we want, of course, to install Containerd. So I can copy it. I'm not really fan to parallelize all terminals. In fact, here for a tutorial it's not a problem, but in production it's not really great, because sometimes you can be unsync for one terminal and you don't take care about it, and if it's finished with like rm-r and on some directory and stuff like that, that can be already critical usage and you need to take care about it. Okay, so first, just to play with the container DCLI, we will be only focus on the left top terminal, so this one, the KADM one. We have 3 masters, like in the previous video, so KADM 1, 2, and 3, and we have 2 workers, the 1 and the 2, okay? So, if we have a look inside the files that you can find inside the GitLab repository that you can discover inside the video description, just above this video, we can make sudo ctr, and we want to say, okay, we have maybe some namespace, and we can list the namespace like here. So no namespace, of course. So we can create a new namespace. So to do that, we want to use create my ns for my namespace, and if I list again, it works perfect. And now I can list how many do we have some container right now. Of course nothing, but I hope, and I can check. And to list a container, we can use the C option here and ls just to list, and it's like it's more like the docker ps command, in fact, and we haven't any container, of course. So now what we want to do, of course, you can imagine, we want just to install a new container in order to handle this one, or to try to manage this one. So to do that, we need first to download, in this case it's an Nginx, so the Nginx image. So basically it's the same thing like you can find for Docker or other OCI image standard. And after that, so we have a new image. So we can imagine, we can use image ls, and we can find the image. Here it's the name of this image. Okay, so now we can create a new container based on this image, like here. Okay, sorry, like here. It's quick, of course, because we already download this image, and we can list not the image, but now we can list the container, and we have one container. Okay, so imagine that we want to remove this container, so we can make crm and the name of this container, okay, and we can't. And it's exactly like inside Docker, you need to stop this container before. So how to stop it? If you just have a look in the help, you have nothing about to stop this container. Yes, it's because it's not inside the container, but it's more about the process, and to handle the process you have the task, and inside the task you have pause, kill, and so on, the start, but you have kill, and you can use kill, for example, reuse. In fact, so you can list first, you can list the task, so you have ls, and you can say, okay, I want to kill this task, so it's a PID, in fact, and now I have, I just stop this container, so if I just list, it's stopped. Okay, perfect. So now I can rm again this container, and it works now. And if I list again if I want to just list all containers, no container, perfect. So now maybe I can say, okay, now I want to remove the namespace. Okay, so we want to remove the namespace, so it's rm my ns namespace, and it's a failed, because we need to have an empty namespace. But in our mind, we already removed we already removed the container. So what do I need to remove right now? And if we have a look at it, but it still has images. Okay, so yes, we have an image, of course. So if I just run -n my ns and image and list or ls, it's okay, my image is here, so I can use rm again, and it can take the image name or reference, and now it seems to be okay. So now I can remove the namespace. Perfect. So this is the CLI, demo, and now we want to prepare our next video. So we need to have our prerequisite to use the kubeadm CLI in the next video. And to do that, we will just go through some CLI. So the first thing so we have containerd, we need to disable the swap first, and we will do it over so across all the cluster, but it's not already a cluster, but all servers that we will have inside the cluster. Okay, perfect. And just after that, so for containerd it's okay, but we need to set again containerd. So we will generate a new default configuration for containerd, and we will use sed to replace the systemd cgroup equal to false to ensure that we will have equal to true, and we will restart containerd. So it's really easy, in fact. So we can copy and paste it on all terminals. So okay. And now we will do the same thing, but for to ensure that we have all modules, so both, in fact, overlay and BR net filter activated. So yes, I can copy and paste it again. Let me just redo it. I'm not sure that what I did. Okay, perfect. Like here, and like here, and probably maybe I can edit this one just to be sure. And of course, I'm already root. Sudo is not really useful here. It's too much, but it's not a problem. Yes, just because I rerun the command, and perfect. And yes, that's it for today. Don't hesitate to subscribe to the channel to not miss the next video with kubeadm, and we will initialize the first node of our first cluster, and you will see it's really easy and interesting to do it. And don't hesitate, yes, to support me with a like or a comment inside this video. And yes, don't hesitate to just clone the GitLab repository, because it's really easy to copy and paste CLI with that. See you in the next one. Bye bye.